Hello, and welcome to this Academy Cloud Foundations demonstration. In this segment, we're going to be speaking about Amazon Relational Database Service, or Amazon RDS. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your applications so you can give them the fast performance, high availability, security, and compatibility that they need. Amazon RDS is available on several database instance types, optimized for memory, performance, or input and output. It also provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. You can use the AWS Database Migration Service to easily migrate or replicate your existing databases to Amazon RDS. In this demonstration, we go through the steps of creating a MySQL database using Amazon Relational Database Service and the AWS Management Console. We then connect to the database in AWS using a MySQL client running on an Amazon Linux EC2 instance. So we are at the console, and we're going to be navigating to the RDS landing page. Once we are on the Amazon RDS landing page, we focus our attention on the orange button that says Create Database. We also notice how the left navigation panel has a number of items related to snapshots, automated backups, query editor, and others. These items are a little bit more advanced, and we suggest that you explore them individually to become familiar with what is it that they do, what benefit they render to you. We're going to click on Create Database. And on the following panel, we get to select the engine that we're going to be using. In our case, the MySQL engine. We get to see Amazon Aurora, MariaDB, Postgres, Oracle, Microsoft SQL Server. In this case, we use MySQL as it is a common database implementation for LAMP stacks. On the MySQL configuration, we're going to click on Next. And RDS gives us a way to be able to choose what type of use case are we going to be applying in this particular case. In our case, we're going to be generating a development and testing database. And we're going to make it applicable for the free usage tier. We're going to click on Next after that, and we get to answer some questions related to this particular database instance. Scrolling down a little bit, on the DB instance class, we're going to scroll up and select T2 Micro. That's going to give us a database engine that's actually applicable for the free tier usage. Because this is a development database, we're not going to be doing multi-availabilities on deployment. We're going to leave the storage exactly as is, and we're going to be disabling the storage auto-scaling. Notice how the panel for estimated monthly cost gives you an estimate of what you will expect to pay for this particular implementation on a monthly basis. On the database instance identifier, we're going to give it a name. For master username, we're going to be selecting admin. We're going to be providing the master password and confirm it, and click on Next. Following that, a number of advanced settings come into play. As far as the virtual private cloud that we're going to be using to land this particular RDS instance, we're going to select Lab VPC. The subnet group, we're going to keep the same. And for public accessibility, we already have it checked. We don't want it to be publicly accessible. We have no preference for availability zone. However, on the VPC security groups, we have pre-provision and RDS security group, which is actually open for the MySQL port 3306. The database name and the port 3306, everything looks good. We're not going to be using identity and access management authentication, so that radio button is selected correctly. We're not going to be using encryption. And for backup, we're going to select 0 days. We're not going to copy any tags. And we have disabled enhanced monitoring. As far as log exports, we're going to leave everything as is. And we're going to be disabling auto minor version upgrades. We're also going to be deselecting enable deletion protection. That's all it takes. We're going to select create database, and that will immediately begin defining our database instance. We select DB instance details, and we get to observe the database provision. Initially, notice on the DB instance status, it indicates creating. We also get to observe how there are a number of CloudWatch metrics already prefabricated as far as being able to observe CPU utilization, DB connections, free storage space, memory, write input outputs per second, read input outputs per second. On the connect panel, under the endpoint is where we will receive, once the database is available, the actual hostname that we will be using to connect. At this point, we scroll back up, and we're going to be using the refresh button as a way of having the page refresh while we wait for the DB instance status to indicate available. Okay, we now get to observe on the info that the database instance, my ACFDB, is marked as available. So we're ready to go and begin connectivity. As we scroll down on the endpoint and port, we're able to then copy and paste the hostname for connectivity to this database instance. We're going to be maintaining a copy of that RDS endpoint here on a text editor. Following this, we're going to be using the MySQL call to be able to invoke the command line interface to the MySQL database. Providing the password then allows us to begin to interact through the MySQL command line interface. We're going to be invoking some table creation as well as some data population of that table. So a total of 5 statements. The first one, create table, defines the schema, and then of course we populate with 4 names, last names, and phone numbers. All of the queries and all of the requests to the instance actually appear to be working correctly. Now let's do a small query to verify. Pasting a small query will give us the proper result. In this case, we're searching for Chris. We get first name, last name, and phone as a table. So we have successfully provisioned a MySQL database instance using the simplest configuration possible, including the database engine that qualifies for the free tier. Using an EC2 instance running the Linux operating environment, we connected to that MySQL database, created a table, populated that table with data, and finally made a small query to verify. This concludes this demonstration for Amazon RDS. Thanks for watching.